Hello again, and welcome back to part 3 of AVR 602's demonstrations. And today we're going to be going over chapter 4 that covers using game objects or GOs, materials, and prefabs. So in this chapter, we're going to explore how all of these can be used to enhance our VR experiences. We're going to use a few additional tools, including ProBuilder and PolyBrush, in order to make custom 3D shapes and environments that will help build our scene. We will also be using Unity packages and the FBX exporter to export 3D objects. In this demonstration, we're going to be making a custom grid of primitive game objects and also adding 3D models for our hands that we can see in game. And lastly, we'll be creating a custom VR demo room to test advanced features. In future chapters after this demonstration, we will make our scene become more robust, covering topics including lighting, post-processing effects, coding in C#, and expanding the render pipeline to improve our visual effects. Now, for this demonstration, we're going to be building completely new scenes starting from scratch. So when I go back into my editor, I believe it would be best practice to take all of these scenes we've made from our previous chapter and put them into a single folder, which we can call Chapter 3, and drag them into our base demo. Well, besides sample scene. So for this week, we're going to make a new set of scenes. In that case, we can put those into a Chapter 4 folder. And with our first new scene called Primitives. So I'll create a new scene, call it 4 for Chapter 4, 01 underscore primitives. When we open the scene, I'll be met with the blank template, including the main camera and directional light. So again, we're going to create a grid with primitive game objects. And again, game objects are the building blocks of Unity scenes. They can be a 3D object, simple shapes, to anything complex like characters and vehicles with rigs and animations. Every game object must, at minimum, have a transform, which gives its position, rotation, and scale. Even you can go and create a 3D object like one of these, or even create an empty object, and it must at minimum have, of course, its name, tag, and layer, as well as a transform. So without further ado, let's get into building the scene. First, we're going to create a plane by right-clicking in our hierarchy, going to 3D object, plane. Make sure that it's centered at the origin at 0, 0, 0 as usual. Next, we're going to add an empty game object that can serve as a parent for all of our primitives and call it primitive holder. So I'll create an empty game object and call it primitives underscore holder. Again, this will be used to hold all of our primitive objects at the same height or level, and we can move all of them around together. We'll start with making a simple cube, which we will give its position of 0, 0, 0. And we're going to name this cube as cube underscore 0.5. I'm calling it cube 0.5 because I'm going to make it have half the scale of a typical cube. And in order to have it sitting on the floor of my plane, I'm going to raise its position to half of that, which is 0.25. Again, the reason I'm doing this is remember that the anchor point is based on the center of this mesh. So normally it's going to be halfway through the plane, and I'll need to raise it up so that the cube is completely above the surface. Next, I'm going to create 2 more cubes doing the exact same thing, but having one cube be size 1. So I'm going to name it cube underscore 1, with its transform set as 1, 1, 1 for the scale, its position at 0.50. And then lastly, I'm going to make a cube that is double the length, width, and height, calling it cube underscore 2. So I'll be setting its scale to 2, 2, 2, and setting its position to 0, what's 1/2 of 2, 1, and 0. Next, I'm going to create a new empty game object and call it cubes. This will serve as the parent for all of these, so I'm going to select all of the cubes and drag it onto the cube's game object so that it is now a parent of all of these children cubes. So I'm telling you this now to avoid making the mistake. Make sure that when you introduce this parent object, the empty cubes game object, or spheres, capsules, etc., that you set its transform to 0, 0, 0 before dragging the children onto it. Now, besides the cube, we're going to focus on a few other objects, that being the sphere, the capsule, and the cylinder, which you've seen from our previous demonstration with interactables. So we're going to do essentially the same process, but instead of just cubes, we're going to use spheres instead. So I'm going to right-click and create a sphere game object. And I'm going to Control-D duplicate it twice to have two other sphere game objects. And just as I did with the cubes, I'm going to rename it as sphere underscore 0.5 for the first one, sphere underscore 1, and sphere underscore 2. So that each of these will have size half, 1, and 2. And just as I did with the cube, I'm going to set their position to the center, scale as their name, and raise it in the Y direction for their position by 1/2 of that to have it sitting above the plane. Now, I understand that these cubes might be kind of getting in the way of seeing your work, so what you can do is we can select the cube object and deactivate it by clicking this checkbox. So we didn't actually delete the cubes from our scene, but they'll be hidden from us, and we can bring them back by clicking on this checkbox again. So let me continue this process for the other cubes. Now that I have all three of my spheres, I'll do the same process, create an empty game object called spheres, and drag all of these under as children. Now I'm going to do the exact same process for both cylinders and capsules. I'll start with the capsule. So with the capsules, I can't put it at half the height and expect to have it completely above the ground, as it seems that this height may only apply to this cylindrical part of the capsule. So I believe that this cylindrical part has a width of 1, as putting it at height 0.5 puts it completely above the plane. And each of these hemispheres have a radius of 1 as well. So in order to put this above the plane, I need to give this a position of 1. So you can set the Y position the same number as for your scale. And then lastly, the cylinder. The cylinder follows the same properties as well. You can just set that number to the same, you can just set the Y position to be the same number as what you're setting for the scale. Now what I want to do is display all of these together such that they don't overlap each other. So first what I want to do is take the small object. I can leave it as it is. As for cube 1, I'm going to place it at position 2 in the Z direction. And as for cube number 2, I'm going to place it at position 4 in the Z direction. Oh, I didn't choose 4. There we go. I'm going to do the same thing with the other objects. What I'll do is take the sphere's parent object and position it at a different X to spread these out. Let's do 2. Now I can see them separately. Same thing with the capsules. I'll take its 1 size, move it to 2 for the Z. Its 2 size, move it to 4 for the Z. And then I can move capsules, X equals 4. And then lastly, the cylinders. Move this to Z2, move this to Z4. And for the spheres, this will produce a picture that looks similar to your textbook. I'm going to move X to -2. So all these are at increments of -2. And now your scene will look something like this, where we have all these different sizes of the primitive objects displayed on a grid for us. We have small, medium, and large sizes. So this is a demonstration of how to arrange all of these objects and size them uniformly on a grid. And in the next section, we're going to create another grid, but this is going to be with spheres that we can assign custom materials to. This will serve as our materials library for future projects. So this section taught us how to create a scene in Unity with different size primitive shaped objects that are arranged on a grid. And in the next section, we're going to create another grid, but this will be of identical spheres that we can assign custom materials to, and those custom materials will act as a library for us to use in future scenes and games. All right, so let's get started creating the library. We're going to make another scene for a materials grid. And again, it'll be a library for our future projects. And we're going to make custom spheres. Oh, and one detail I forgot for our primitives scene, this primitives holder is supposed to be the parent object for all of these shapes. So let's select all of these and put it under primitives holder and then save. We're going to duplicate this primitive scene and we're going to rename it as 4_02_ materials grid. So one thing that I forgot is this primitives holder is supposed to serve as the parent object for all of these other basic shape game objects. So what we'll do is we'll make its position 0, 0, 0, select all of these empty game objects and drag it onto the primitives holder so that now all of them will move together as one. Now for this next part, we won't be using the primitives holder, so you can actually shrink it and deactivate it or hide it. We're going to make a new empty game object and call it materials grid. Make sure, just as good practice, to always set it to the origin, even if it's an empty game object, so that we avoid some of the issues we ran into last time. We're going to create another empty game object and call it red. Within the red game object, meaning we're going to add a child to it, you can right click on it and create a sphere. And we're going to keep it as a unit sphere, so we'll raise its height to 0.5 such that it is above our plane. And we're going to name this sphere red_standard. And we're naming it red standard because this will correspond to the standard material that we'll be giving it. Now we're going to duplicate this sphere 5 times. So I'll Control D 5 times. Now I'll have 6 spheres in total. And I'm going to change this suffix for the sphere name in each of these. I'm going to change the standard part to metallic. This one is going to be named red_unlit, UNLIT. Emission. And specular. Looks like the book may have misspoke. There's only supposed to be 5 spheres. So we have standard, metallic, unlit, emission, and specular. And these are the different types of materials that we can have. So we're going to align all of these and separate them by a distance of 2. This is at 0. We can take the metallic sphere and put it at z = 2. The unlit can be at z = 4. It'll be at -2 and -4. The order isn't really important as long as they're spaced apart from each other by 2. Right, so we've placed them on this grid at units of 2. And what we're going to do is we're going to take the entire section and duplicate that as well. We're going to make 6 total colors for us to have. So we will rename this orange, yellow, green, blue, and violet. Now, the issue we're going to have with these is these will all have to be renamed as well. So I can just copy orange from here and then paste it on the red name. All right, now that that's done, we are going to take all of these colors and we are going to arrange them on our grid, separating them by units of 2. So in that case, I can have the red be at -5. Oh, that should be along the x-axis this time. Then orange can be at -3. Yellow at -1. Because I have 6 of these, I'm going to distribute it with odd numbers, 3 and 5. All right, so here's our new grid. Now we're going to make our library of custom materials. As I mentioned, there's standard materials, there's metallic materials, unlit, emissive materials, which means they emit light, and specular materials. Fortunately for us, Unity provides a variety of built-in shaders. So the difference between a material and a shader is the material is what is reflecting the light. So in the game, you have a light source that, just like in real life, bounces off of an object. The material determines how that light gets reflected. The shader is how essentially the camera will process that reflected light and be transformed into what is displayed to us. First, there's the light source, then there's the material, then there's the shader, and then that reaches our screen to get rendered. If you actually click on one of these guys and zoom in, well, you don't have to zoom in, but if you look in its hierarchy here, the material is applied on the mesh renderer component. So you have the mesh itself, which is a sphere that describes the actual shape of the object. And then you have the mesh renderer, which determines how the lighting will interact with it along with its material. So we've done this before, creating a material by right-clicking in our assets or project window and clicking on material over here. And then you would get a new material, which you can choose the color and change the rendering mode as well. We've already made a materials folder, so for this chapter specifically, let's just make a folder and call it chapter 4 materials so that we know we're referring to this specific section. Now, based on the naming convention that we are using already, this first material is going to be called red_standard. We need to make sure that the rendering mode is opaque, and we are going to set its color to red. In order to do that, to get a pure red, we can choose RGB values and set the R all the way to 255 and G and B both to 0. Now we have a pure hue of red, which we can drag onto our red standard object, which is this one over here. Make sure that you have both metallic and smoothness set to 0. So it doesn't actually have any of that smoothness or glossy look that glass may have if this were a glass bead. When we set the smoothness to 0, this should also be set to metallic alpha. Next, we're going to make a metallic type of red. So I'll make another material. Call it red_metallic. This time, I'm going to choose the same albedo, which is the pure red. So you can actually just drag it into this top corner and set pure red for you. And we're going to make sure that the metallic is set to 0.75. And then we are going to set the smoothness to 0 as well. And this will be applied to our metallic red object over here. Oh, sorry, the smoothness should also be set to 75. So now this looks like a more metal material, as the name suggests. Next, we're gonna make the unlit material. So create a new material and call it red_unlit. So up here in the shader, we're gonna actually change from standard to unlit. And we can choose color. This gives us one almost solid looking color. We drag it onto our unlit ball and it will be completely just red with no depth perception to it. It almost looks as if you took a red 2D sticker and just put it on your screen. Now we're going to make the emission material. Go to create material. We're going to call it red_emission. Also make it red. And now we're going to check the emission box. And for the actual emission color, emission again means that it emits light, so it'll act like a light source, it'll glow. I believe there was probably an error in the way that the book told you to enter the RGB value, so just choose something that resembles glowing but is still red, and set the intensity to 2. Now for the very last type of red, we're going to create a specular material. I was pronouncing it specular earlier, but I'm pretty sure it's specular with the way that it's spelled. Now this one, for the shader, I'm going to click standard specular setup and change the rendering mode to transparent. I'll still make the albedo red, but I'm going to change the smoothness to 0.6. And then after I've dragged it on, I finally have all of my materials for my reds. So what I can do is I can just duplicate all of these and create orange, yellow, green, etc. So I'll kind of leave the work for you to do. You don't have to watch me do all of this. All right, that's finally done. Apologies on how long and tedious this may have been. You'll only have to do it once, I assure you. Um, and so we actually have some recurring colors in this case, like the reds. You can save them as what's called a swatch, and creating your own swatch in Unity, SWATH, it allows you to save and easily access colors, so that you have like if you plan to use them in your project. They're going to be useful to maintain consistency, so you're not using slightly different shades of red and you want to use the same reds. So to save a color in the swatches feature, you can do the following. So I click on the color picker and I go to swatches. There's an option on the right over here. If I click the three dots, it says create new library. And I'm going to give this a name. For example, we could call it basic colors. Basic colors. I can save it in my preferences folder and hit create. Such that now, if I'm to click on my color picker again, I can set it to basic colors, and every color that I want to add, I can click add it to this preset on basic colors. If I go to edit my blue, and I want to use, I don't mean to do that. If I click here, my red that I just added to this library will be here. So if I click on it, on the blue, it'll add it to my library. So I can just go and add all 6 of my main colors that I've created to my library, so that I can make sure that I'm using the exact same shades of red, green, blue, yellow, etc. every time. Now, enough of the grids and materials and basic shapes and all that for now. What we're going to do is we're going to download assets and game objects from the internet. You can do this by exploring Unity's asset store, which is a marketplace with a lot of assets that are either paid for or free. We're going to be using a custom hand asset that has pre-made 3D models that can be imported into Unity. We can go to the asset store. There is a couple of these that we're going to be using from the textbook. One is these stylized simple hands, and there's also a ghostly hand shader if we want to be able to see through our hands. So we're going to add this to my assets for both of these. Click accept. You should be signed in on your Unity account. You can choose to open it in Unity. Right now it says fetching assets. So looks like if you're having some issues, you may need to sign out, close, and reopen and sign in on your Unity hub. So at least that fixed it for me. So I have the ghostly hand shader. I'm going to click download, and I'm also going to download the stylized simple hand. So all of the assets that you own from the asset store should show up here. Now that we've downloaded them, we can import them into our project. Hit import. Now we're finally back on track. So see, we have ghostly hand. We also have simple hands folders in our project now. What we're going to do is we're going to make a new project for these hands. Sorry, scene, excuse me. It looks like there's a bit of a discrepancy with the textbook. The way that they edit the hands is not in this scene, but it's actually an extension of the interaction scene we've had from chapter 3. So let's go ahead and duplicate the socket interactor scene, drag that into our chapter 4 folder, and start from there. And we'll rename it 403 VR hands. So we're going to continue our interactions table. Let's click don't save. So we're back to this scene now. And if you remember from our last chapter, we had a sphere to resemble our left hand for the direct interactor that had us, we needed to get close enough to an object to be able to interact with it. I don't like having the camera in the way. Let's hide that for now so we can see what we're dealing with. So in this scene, we're going to locate the controller game object, which we had our left hand and our right hand. And what we're going to do is we're going to select the stylized simple hands. So we have prefabs for our hand models. You can pick either, or it doesn't matter. So we'll drag one of our hands into the scene. And you may notice that it does not have a material. That's why it's all pink. If I drag it onto my left controller, give me the position to 0, 0, 0, it's going to look a bit like this. And since it's my left hand, in this case, I'm going to want to adjust it so that it fits my left hand. Now, of course, these hands do not have a texture applied to them or material. So we can use the Ghost Hands material, which should be found in Ghostly Hand, the folder. You can import this built-in renderer. It's an example material. You can also import this for URP. This is an example hand material, and I can just apply whatever preset I want. Let's go with one of these. I'm gonna try to fix the hand so that it's facing forward. When I input 0, 0, 0, this is what I get. So I'm gonna have, and this is me holding my hand directly in front of me. I'm going to have to adjust the numbers over here. There we go. Okay, so the Y is facing forward. Now I gotta rotate it like this. Try changing the Z. Alright, so after messing around in play mode a bit, I was able to find the correct transforms for the hand objects. So here they are. 4.5 for all of them, for all the scale. The rotation 4, -170, -70 for the left hand. And for the right hand, I mirrored it by flipping the X, making it negative, and set the Y rotation to 4, -170, +70. Now that we've got some more sophisticated objects to represent our hands, let's find some assets to replace our primitive objects with that are also a bit more sophisticated. There's this food pack that we're going to use, and we're going to use some of these 3D models to take the place of our primitive shapes. So we can open it in Unity. Open. It's fetching the assets. Click download. Now once it's downloaded on our computer, we can click import. These are some relatively low poly objects, as listed in their description. That will allow us to have fast performance still. As if you have high poly count 3D models, that might slow down your game. Once we've imported them, they actually show up in our assets folder under food pack demo. So once I open this, they're all in here. In the prefabs folder within this, I have all of these sample objects. It looks like they don't yet have the material applied to them. The book chose a coffee cup, ketchup bottle, peach, and a sake cup. And you're to change the shader for all of them to standard. So let's look for coffee cup, that's here. Change the material to standard, and that should allow it to render for us. Down in this little preview window we have. So in order to replace them, each of these primitive objects, let me close this, go back to our VR objects. I'll start with the cylinder first, the cylinder multi-interactable. So we're going to select the object that we want to replace, which is the cylinder. And we're going to place the new food objects prefab as a child. I'm going to take the coffee cup and use that to replace the cylinder by dragging it onto it as a child. So now this will have the same transform center location as the cylinder. And as you can see, it's kind of embedded within it. It's a little bit small. So in order to replace this mesh, I'm going to scale it until it fits. So it looks like it's about this wide. I can make it taller, but that means I'm going to have to lower its center a little bit. Oh, and I'm going to have to scale it in the Z as well, which I probably should have the same as X. So let's keep those the same. I'd say that looks close enough. Okay, now I'm going to go to the cylinder's mesh renderer and turn that off. So I'm essentially replacing its mesh with this 3D object. So now I am, after hiding the mesh renderer for this one, I'm going to do the same process with each of these other objects. And you don't have to choose the same materials or same objects as the book. All right, so after that, I've got my no longer primitive objects, but I've got more sophisticated 3D models for these. You can test to see if this works correctly. I'm not going to waste time doing that, but I'm just going to have faith that these will behave the same as they should physically. The next thing we're going to do is create a custom demo room using ProBuilder. So we are going to physically build a building around this room. This will become a room using ProBuilder. And we can actually create a template for it by using Google Drawings to design the floor plan, visualizing our layout and the dimension in space. And we're going to create a floor plan just like the one with the book. The way that it looks is we're gonna make some rectangles or use the square tool, this one here, to draw a large room that is connected to the main scene by a couple of hallways and 2 more smaller rooms. So it's gonna look something like this. We have the main room, which is a square. Hopefully this matches the dimensions of our floor that we made in yellow with our teleportation planes. We're also going to have a larger back room that should align with this. Then I'll add my smaller hallways. Duplicate this. Try to make it symmetric. And lastly, I'm going to add these 2 other rooms on the side. They're a little bit smaller than my main room. Now, I'm not sure if the order of this will matter, but just in case, I can move these to the back. Now, it looks identical, practically identical to the one in the book. Now what we're going to do is we're going to download this as a JPEG. Untitled drawing, that's fine. And we're going to import this floor plan by going into our textures folder, which we don't have yet. We can create one. Create folder, textures. I can just drag into my textures folder. So now we have it in Unity. And we can select it and change the import settings in the inspector over here to Sprite 2D UI. You go here, Sprite 2D UI. And I'm going to click Apply to apply these changes. So now what we're going to do is we're going to use ProBuilder to make this a 3D room from our 2D object. Because obviously, in real life, not every object is derivative directly from a sphere, cylinder, cube, etc. I mean, technically you could make a lot of objects with these basic shapes, but it would take you a while. So Unity has a tool called ProBuilder that you'll need to install. Go to the Unity registry, see if it's in here. Oh, here it is, ProBuilder. Okay. You open your package manager, go to your Unity registry packages, and you can click install, get ProBuilder. It allows you to build, edit, and texture custom geometry in Unity. So this will allow us to edit 3D models directly in Unity without having to use some kind of third-party software like Blender or Maya. All right, now that it is installed, we can create a new ProBuilder object. Apparently, the book says you can access ProBuilder in the Windows tab, but apparently, for some reason, it shows up in the Tools tab instead. If I click ProBuilder window, there's a whole list of functions and capabilities that this has. Like, you can make a new shape, new poly shape. It'll add it here, and you can create it by simply connecting dots together, extruding them. It has a whole series of things. Most of my 3D modeling experience comes from Blender, so I'm not as familiar with ProBuilder, but if you just look up ProBuilder documentation or tutorials, there's plenty of resources out there if you're into learning how to 3D model. But what we're going to do is create the 3D model based on the drawing for our floor layout. Specifically for this, we're going to save and then duplicate our scene and give it a new name, which we're going to call this 4_04_. Sorry. Looks like I skipped a scene again, so we're going to call it 405. The previous scene was for the custom objects that I put on the table. I'm going to call this _demo room. Now we're going to make the rest of our building for this by converting the floor plan. So we have our floor plan in our textures folder already. So we can just add this image into our scene right here. And you can see it's orientated straight up. So we need to rotate it 90 degrees. So we can do that on the x-axis such that it is now on the floor. So we've positioned the scene, the floor in our scene, but we need to scale it such that it fits to the size of our plane. honestly, I think that's good enough. Right about there. Okay, so now that we have this leveled and set up, we can create a new empty parent object and call it demo room. So we're gonna fit this floor in our demo room. And we should have the ProBuilder package already set up, and we're going to go to our ProBuilder and select new poly shape. And this will help us in tracing over our floor layout shape. Where should I put this? I'll put it along with the inspector because I don't need to look at any game object details right now. It doesn't have to line up perfectly as long as it's something close. It'd be nice if there was a keyboard shortcut that I knew to have the lines be at 90 degrees. But I'm not too familiar with ProBuilder. I'm gonna just have to eyeball this. And there we go. So now that we've placed a vertex on every corner, Polyshape tool has this extrusion feature which allows us to extrude the shape off the floor. If I hit enter for 4, might not, hold on. Yeah, make sure that I have this one selected. There we go. Now that I've hit 4, it gives us some height, and then click flipped normals, and there. Now we have our, I quit editing. Now we have our prototype for our rooms. I can probably hide this 3D floor mesh now, since it's kind of overlapping a bit. Let me turn off the mesh renderer for it. Now what we have looks something like this. Now I can get rid of the drawing that we used for it. This poly shape, I can rename it as rendered room. I don't know why they decided to use all lowercase, but this will be added to the demo room object. This should be a parent object to all of the items in the room. As per usual, before dragging in the children, I should have set the demo room's transform to 0, 0, 0. Very common mistake, at least by me, so make sure that you do that. Also, this doesn't have a material, which kind of bothers me. I want a closer to white color that contrasts this more saturated color. Let's rename it as room. Make it be like a softer purple that complements this. A lavender color. Drag it in. There we go. So let's go ahead and test the scene and see what it looks like. And here we are. We are inside of our room. I'm assuming that later in the course we'll have animations for our hands to be added. I find it really cool that the sockets match. Looks like everything is still functional from our previous demonstration. Another tool I have to share with you when it comes to editing your assets is Polybrush, which is another extension of the Unity Asset Store that allows you to sculpt or paint onto your textures, materials, and adding colors. We're going to make these changes in another scene. We can save, duplicate. The book actually doesn't use this purple material on it. I'm assuming that it creates a new one. We're gonna rename this as 4_06_ decorated room. Now we're gonna go to the same window for the package manager that we downloaded our Pro build for, and we're gonna search for Polybrush. Here it is. Install it. Once it's finished installing, you'll also have its own window under Tools here. You can make a Polybrush window that I'll place along with the Pro Builder window. So this will let us create new materials by simply drawing onto some of the pre-existing meshes. We have to create the new materials first. So we can go into our Chapter 4 materials, create a new material. We'll call it Vertex Paint. Vertex Paint named after one of the features in Polybrush. We should actually change the shade. We should change the shader to become standard vertex color. Now this is essentially going to collaborate with Pro Builder. Let me redrag this on. This is what I had originally as my walls. I can go into the Pro Builder window and use the subdivide face. So what you're able to do is you can actually select a vertex, which is like a single point, or you could select an edge or a face. Maybe I want to choose this face specifically, and there's an option to subdivide faces. So it inserts a new vertex at the center of each face and splits it into 4 additional rectangles. This will give you more control over what you choose to decorate. So let's just say I want to select this one up here, so it splits it one of these rectangles. The more vertices you have, the more freedom you'll have to decorate your room. Looks like I need to choose this paint vertex color on meshes. And so this will let me essentially draw on here. Let me choose maybe like a blue. Oh, here we go. So I'm not too much of a 2D artist myself, but you may have to fiddle around with this tool to apply your textures or drawings, however you want to change this. You also have like a fill tool that you can apply this with. But yeah, I'm not exactly sure on how this tool completely works, but if you want to look into it for artistic purposes, then by all means go ahead. I'll kind of save that for your own work. There's also this voxel low poly furniture assets, if you'd like to add those as well. All right, so now that we've decorated this a little bit, we can also create prefabs with our game objects. So prefab is short for a prefabricated object or asset, which we can essentially copy and paste and use into not only separate scenes like things in our assets folder, but we can bring them into separate Unity projects. So everything in our projects folder essentially acts as prefabs, where if I, for example, wanted to make my XR rig a prefab, I can do that. So I'm going to make a new parent object, create it empty, and call it VR rig. And this will serve as the parent for multiple objects. So I'm going to set it to 0, 0, 0 on the transform. And it's going to be the parent object for our XR origin. I'm also going to add the interaction manager and the locomotion system to it as children. So now that if I wanted to make a completely new scene from scratch that has VR capabilities, I can drag the VR rig directly into it, have my hands working, and all the functionality still there. So what I'm going to do is drag this into my projects tab. And now it has my XR rig set up as a prefab. This says root in prefab asset. Notice that it highlights it in blue, showing that this is the original prefab. I can even make another prefab for my floor, for example. Create a new empty, and maybe I could call it teleport floor. And I can drag the teleportation areas into it, along with the floor. And then drag this into my projects, and it'll automatically become another prefab that I can drag into another scene that's completely blank to use. Let's say you want a slightly different version of one of these prefabs. What you can do is you can right click on this, one of the existing objects, and choose prefab variant. So what you can do is you can directly go into the prefab and edit it. So let's say that I want to make the hands a little bit bigger for some reason. I can go ahead and change those assets, like the stylized hand, and make it a bit bigger if I wanted to. I'm not sure why I would do that, but then I could copy and paste a prefab with a bigger hand. So if I just wanted to make a copy and make some small changes to it, I can escape out of this by either clicking back on my scene or clicking this little arrow on the top left to go back to my original scene. So if you want to actually organize these, we can put these into a new folder called prefabs. To create folder prefabs. We can drag all of these into there. The next part of the book talks about just organizing your whole project, which I've already explained that it's good practice to make folders for materials, prefabs, audio, sounds, textures, etc. So in that case, I will lastly explain about exporting project assets and Unity packages with FBX export. There's a few ways you can do it, but The main way is using another package that you can install called the FBX exporter. Go to Unity registry, go to FBX exporter. An FBX is a type of file used for 3D objects. If you're familiar with 3D modeling and using software like Blender or Maya, FBX is one of the options you can use to export 3D meshes or 3D objects. So for example, I can take a Unity prefab and export it as a package that will be compatible with Unity. It will actually export it as a Unity package. So if you were to send somebody else who's using Unity assets, you could export it as a Unity package and they can import it, kind of like what we've been doing from the asset store. If you had something like this cylinder mini model that you wanted to export, you can right click on it and choose export to FBX, and you can choose what you want to include in it, where you want to save it as, along with some other settings. All right, so this lesson was a bit of a doozy in terms of the amount of time I needed to put this together, but we were able to add some decorations to our scene, improve things like materials and textures and decorations while maintaining the functionality of our game. And so we have a pair of hands. We also have some food items on our table that we can still interact with in the same way, along with an actual building that we used Procreate to construct the 3D mesh for, and Polybrush. I hope that you found this tutorial useful as with the others, and I will see you in our next chapter when it comes to implementing physics and animation.